In this lesson, we're going to look at something called similarity. Now, two figures are said to be similar if they're basically the same shape, with one being an enlargement or a reduction of the other. So, if you look at this idea here, I'll just take, for example, let's take a pentagon. Now, to create a similar shape, all I need to do is clone the pentagon and either make it a bit smaller, as a similar shape, or make it a bit bigger. Just by dragging this corner point out, it enlarges it. Now, what it does is it enlarges it using a scale factor, so all the parts are enlarged. The main thing to look at here is the corresponding angles are equal for a shape to be similar, or the corresponding sides are in the same ratio. So for example, this side here, if you look at it, I'll just get a highlighter pen, and this side here, their corresponding sides, they should be multiplied by a scale factor that's exactly the same as this side here and this side here. So say this side here was tripled, that side at the bottom would need to be tripled in size, and that side there would need to be tripled in size, and that side there would need to be tripled in size. All the parts would need to be multiplied the same way. Okay, the easiest way to see this in real life, I suppose, is with, if you go into a toy shop, you get reductions of real life models, and all the parts are exactly the same size but on a smaller scale. Sometimes trains, sometimes cars and planes, etc. Okay, now to prove that the two pictures shown below are similar, you can either do corresponding angles are equal, or you can look at corresponding sides in the same ratio. In this picture here, this diagram, I don't have any angles, so I'm just going to go for sides. To prove two pictures shown are similar, so we're going to look at the scale factors. Now the first thing I'm going to do is look at the breadth scale factor and see what it is. Now to work out what that is, basically what you have to do is take this number here and divide it by this number here. There's the corresponding sides, the breadth's at the bottom. So if I take those two numbers and divide them, I'll get a numerical answer. 4.2 divided by 7 is 0.6. Now I always go from the second shape and divide the first number. The reason for that is you can see that this shape is getting smaller. So the scale factors, if you're getting smaller, should really be less than 1. To make something bigger, you should really multiply by something greater than 1. So if you do the second number always divided by the first number, you'll get an appropriate scale factor. So if this shape is similar, then the 11 and the 6.6 should also generate the same scale factor. So let's have a look at that. So I'm going to take this number here, again 6.6, and divide it by the 11, the corresponding sides. So 6.6 divided by 11, comes out exactly the same, 0.6. So because, and then you put a wee statement at the end, because the ratio of sides are equal, the picture's similar. Okay, the last thing I'm going to look at in this lesson is sometimes you have a missing value to work out. So it says, we've got two examples to look at. It says these two shapes are similar. Okay, so calculate the enlargement scale factor. Now to do that, let's do that first. You look at the sides that are corresponding. So I can see that I've got a 6 at the bottom and I've got a 15 over here at the bottom. So if I divide these two numbers, remember to do the second number divided by the first number, I'll get my scale factor. So that should work out as 2.5, 15 divided by 6. My working's here and I'll show you in a second. What we have to do is try and work out this height here on the bigger shape. So 6 has been multiplied by 2.5 to get 15. So we need to do the same to the 8. You take your 8 and you times it by 2.5 to get how high this is. What that looks like is this. Write your scale factor. 15 over 6 is 2.5. Just do that in your calculator. Then take your 8 and then times it by 2.5 and you'll get how high the second shape is, which is 20 centimetres. Okay, let's look at this last example. These two cars are similar. Calculate the reduction scale factor. So this has got smaller. There's a wee trick here. This big car has got 2.4 here and the small one's got 30, so this number 30 looks bigger than the 2.4. However, we have to think about we're in meters here and we're in centimetres here. So when you're doing your scale factor, your reduction scale factor, what you need to do is change them into the same units. It doesn't matter which way you go here. I'm going to choose to work with centimetres. So I'm going to just change this and I'm going to say, well, 2.4 metres, there's 100 centimetres in a metre. So that's really the same as 240 centimetres. So when I do my reduction scale factor, I take my second number and I need to work with corresponding sides, so there's my 30 and I'm going to use the 240. So I'm going to do 30 divided by 240 and get my answer. Now that's over here, I think it's 0.125. Now all you have to do after that is take your 1.2 here and times it by 0.125. Again, because you've got a reduction scale factor, your scale factor should be less than 1 to make things smaller, basically. So when you multiply with things less than 1, you make things smaller. So 1.2 multiplied by 0.125, let's have a look at that. It comes out to be 0.15, but that was in metres, so again I've just changed it to centimetres. You could write 0.15 metres, I've just changed it back to 15 centimetres because that 30 was in centimetres.